A lot of people confuse SageMaker Processing and SageMaker Batch Transform. And honestly, the names don't help, but they solve two completely different problems. In this video, I'll show you the key differences, the architecture behind each one, and simple code examples so you know exactly when to use which. SageMaker Processing is used for data-related workloads. You can run custom Python, Spark, or scikit-learn scripts. It does not require a trained model. Batch transform, on the other hand, is specifically for inference. You must already have a trained model. It performs large-scale predictions on data stored in S3. So the simplest mental model is this. Processing prepares data. Batch transform generates predictions. In real production systems, we usually don't run just one processing job. Instead, an orchestration tool like Airflow triggers multiple SageMaker processing jobs as part of a DAG. For example, the first job might filter raw data from S3. The second performs aggregation. The third does feature engineering. Each of these jobs runs inside its own container image stored in ECR. The data flows between S3 buckets, and SageMaker spins up temporary compute for each stage. Airflow controls the sequence, while SageMaker handles execution and scaling. This is how processing fits into modern ML pipelines. Now let's look at the architecture of SageMaker Batch Transform. Unlike processing, this workflow is model-driven. First, we have a trained model artifact stored in S3. This contains the serialized model, for example, a model.tar.gz file. Then we have a separate S3 location containing the batch inference data. This could be millions of records that need predictions. When we start a batch transform job, SageMaker spins up inference instances, downloads the model artifact, loads it into memory, and reads the batch input data from S3. It automatically splits the input across multiple instances for distributed processing. Finally, the prediction results are written back into another S3 location. No endpoint is deployed, and everything shuts down automatically after completion. So this is fully managed, large-scale, offline inference. Let's look at how we actually create a processing job. In a typical project, we have two files. The first is processing_job.py, which launches the SageMaker job. The second is preprocessing.py, which contains the actual data transformation logic. Both files usually live in the same project directory locally. When we call script_processor.run, SageMaker automatically uploads the preprocessing.py file to the processing container before execution. The sclearn_image variable refers to an official SageMaker scikit-learn container image. We retrieve it dynamically using SageMaker.image_uris.retrieve, which ensures we're using the correct AWS managed container for our region and framework version. Then, SageMaker provisions the instance, runs the script inside the container, uploads the results to S3, and terminates the compute automatically. So we focus on writing Python. SageMaker handles the infrastructure. Now let's look at batch transform from a project structure perspective. Unlike processing, we don't have a local inference script. Instead, we already have a trained model artifact stored in S3, usually a file like model.tar.gz produced by a SageMaker training job. In our project directory, we just have a Python file, for example, batch_transform_job.py, that launches the batch transform job. The xgboost_image variable refers to the official AWS managed xgboost inference container. We retrieve it dynamically using SageMaker.image_uris.retrieve to ensure compatibility with our region and version. When we create the model object, we are telling SageMaker where the trained model artifact lives in S3 and which container should load it. Then we create a transformer, specify the instance count, and call transform. SageMaker spins up inference instances, downloads the model artifact, loads it into memory, processes the batch input data from S3, writes predictions back to S3, and then shuts everything down automatically. So unlike processing, here the container already knows how to perform inference. So when should you use each one? If you're preparing data or running custom workflows, use processing. If you already trained a model and need large-scale predictions, use batch transform. Processing is flexible compute. Batch transform is managed inference. That's the key difference.